Buongiorno baddies, welcome back to another video. Today's only question is, what is the greatest number of acute interior angles that a decagon can have? So firstly, let's deem the number of acute interior angles as x, okay? X is our good old handy number. And since a decagon is a 10-sided polygon, let's deem the amount of obtuse angles that this decagon has as 10 minus x, since it's the total number minus the amount that is acute angles. And you might be like, okay, but what are we going to actually do with this information? Let's just deem the total sum of the acute angles as SA, acute, I guess. And deeming the total sum of all the obtuse angles as SB, because AB, why not? So, SA, since a acute angle can't be a 90-degree angle, therefore it has to be under 90 degrees, it's definitely going to be less than 90 degrees of x. Since x is the number of angles, and 90 degrees is the maximum of what you can push, but it still has to be underneath that because, as I said, an acute angle cannot also be a right angle. That is two different things. And similarly with our obtuse angles in SB has to be less than 360 degrees, 10 minus x. Once again, this is the number of them, this is how much each one is, and similarly it cannot be 360, it has to be under than 360. So now that we have this sort of equation kind of thing starting to pan out, we can combine SA and SB to get the total interior angle sum of our decagon. So SA plus SB. And SA plus SB, since SA is less than 90 degrees times x and SB is less than 360 degrees times 10 minus x, this means that SA plus SB will have to be less than 90 degrees x plus 360 degrees 10 minus x. So, how do we know what SA plus SB is equivalent to then? SA plus SB would be just the interior angles of the decagon added together, and using our nifty little formula from a lot of previous problems, n minus 2, n being the amount of sides that our polygon has, multiplied by 180, in this case it is equivalent to 1440. So SA plus SB is equivalent to 1440. So if we plug in 1440 in the place of SA plus SB, we can just start solving, because now we have our numbers, we have an inequality, and we can start solving with it. So let me just write out the equation one more time. 360, 10 minus x. And firstly, we're going to distribute the 360, yada yada yada, regular algebraic inequality. So 1440 is then 90x plus 3600 minus 360x. We're going to combine the 90 degrees x and the negative 360 degrees x right now. And we're going to scoot the 3600 to the other side to get 2160 degrees. It's less than negative 270 degrees x. Multiplying both sides by -1, be careful here, you're going to have to flip the inequality sign, but 2160 degrees is greater than, not negative anymore, 270x. Divide both sides by 270. 2160 over 270 greater than x. So if you simplify, get rid of this 10, divide by 9, so 3, 24, 8. So 8 is greater than x, or in standard math fashion, x is less than 8. And you might be like, oh, well then 8 is probably the greatest it can go, right? But you can notice here that I did not write x is less than or equivalent to 8. Therefore, 8 is out of the boundaries of our numbers. Therefore, if we subtract 1 because it can't be a decimal number of angles, we're going to get x can be less than or equivalent to 7. Therefore, 7 here is our final answer. So the greatest number of acute interior angles that a decagon can have is 7. So yeah, that's the end of this video. I hope you guys enjoyed it, and I hope you guys learned something new, and I will see you all on the next one. Bye-bye!